And I might add these are tech-free questions, being paper 1. So we've got order of operations here in this first trigonometric question, and we've got a restricted domain. Okay, or some may say restricted range. Firstly, we need to determine with order of operations what's inside the inner part, the bracket. So that's your sine. 4 pi and 3 is what we need to determine first. And we can easily determine that exact value if we know from our math methods some basic trig. 4 pi on 3, to do a rough sketch, is over there in the third quadrant, and we know that the sine values are negative in the third quadrant. Sine 4 pi and 3 could be considered to be equivalent to the negative of sine pi and 3, which is negative root 3 on 2 as an exact value. So thus we're finding arc cos, or inverse cos, of negative root 3 on 2 with the restriction given above there. Okay, and that would just mean that there is one value that's sufficient for that, and it would be 5 pi and 6. Again, that's due to that restriction for y. And that correlates with answer D. Significantly, in question 2, we have a normal distribution, so that's significance. Even though our sample size is only 9, we have a normal distribution. So there's a few things we can use from that. With the central limit theorem, we can say that the actual mu mean, which is 4 hours here, is equal to the sample mean. So the mean of the distribution is the same as mu. Okay, so we can say that 4 hours is also the value for x bar. The standard deviation is 36 minutes, usually given by sigma. And because of the central limit theorem, we've got, for the sample, the standard deviation is 36 over the square root of n. N is 9, so it'll be over the square root of 9, which is 36 on 3, which is 12 minutes. So that correlates with a distribution of 4 hours for the mean, and standard deviation of 12, which is option D. For circular motion, we need parametric equations in the form this basic form. The symbols may change, but the form essentially is r cos theta I plus r sin theta j for the position vector r. Okay, so, and that's what we're looking at here. All right, so that maps on to what we've got. We've got equations in terms of r of t. So we need to look at one which is consistent there. So it has a consistent magnitude r there, and it has a consistent real number parameter there. The only one that has that is option D, because we can map 2t onto theta or theta onto 2t, and we've got a consistent value of magnitude r there. If you have a look at the others, they do not possess that characteristic. So that comes from parametric equations for circular motion. Question 4 is a vector question, and to me it's just really just knowing some content for three-dimensional polar form vectors. And you can see the diagram and the lead in there, and the angle that represents the altitude of the vector OA. The altitude angle sometimes is given by phi, but basically it relates to the projection of the vector on this xy plane down here. Okay, so what part of the vector, from the part projected down onto the xy plane up to the vector itself, is the altitude angle. And so we look at an angle there that corresponds with it, and it's AOB. So AOB gives us that angle. None of the other ones do. The last tech-free multiple choice for this particular video, and it's basically understanding a concept and also knowing a bit of content. And confidence intervals are often misinterpreted, so it's a handy sort of question to have your head around. So it's important that with confidence intervals we've got a 95% confidence level here. So the confidence interval really says 95% of such samples, so samples taken in this manner, will contain the population mean. The population parameter. More generally. In this case, we're talking about the mean. In math methods, it might be the population proportion. Okay, so the claim, here's the claim. All right, it's a claim. We're testing that claim essentially. The claim is that the mean is 50. Let's run through these four options and work out which one best describes it. Okay, and it does say best, so there may or may not be elements of truth in each of the options there, but we're after the best one. Okay, the first one here, the company is using false advertising. Now, we've got maybe some cause for some people to say that, but it's not actually something we can conclude. All right, now what might lead people to think that possibly is that if we look at the confidence interval and the claim is outside of that confidence interval. Okay, it's above 49.6. But that can happen. All right, we're 95% confident, so 95% of such samples involving 350 samples of boxes, chunks of 350 boxes. They should contain the population parameter, but not all of them. So it could be that you could get boxes beyond that. So while some people might lean towards that, it is not something we can conclude because it could. The mean can still sit outside of that. Okay, it's not 100%. So the next one is not true. 95% of the companies, it's not a proportion statement. 95% of the companies' match boxes do not contain 50 matches. Again, it's more about 95% of such samples will contain the mean. Okay, so that is not correct statement there. And when you analyze what that says, 95% of the company's match boxes do not contain 50. What? That's not what we're talking about at all. All right, so if we perform the samples in the same way with the same parameters there, the same specifications, I should say, 95% of our samples should contain the actual mean, the true mean of the population of matches. Okay, so it's nothing about a proportion that do not contain 50 matches. No way. All right, I'm deliberately skipping C. I wonder why. D, the sample size is too small to draw conclusions. It's not too small. Okay, because Peter takes samples of the number of matches in 350. There's your sample size. Okay, so we're measuring in basically samples of the number of matches in 350 boxes. It's a sample of 350, so n is easily greater. It's 350. It's easily greater than 30. So that's not true. So that must mean C is the answer. There's a statistical basis for being suspicious. Yes, there is, because it's a little bit like A, but A is not right. We can't come to that conclusion necessarily. Okay, we cannot come to that conclusion necessarily, but there is a basis for being suspicious because again, 95% of such samples will we would expect to contain the population parameter. Okay, if we do bunches of 350 boxes, so yes, we would expect their claim to be sitting in there. But it's not a guarantee that it's a false claim, but we are suspicious, and maybe more quality assurance or more investigation needs to occur.